Alright, so for today we're actually doing the trig ratios and sine, cosine, tangent. I don't know why this is not, there it is. Alright. Okay, so for this one right here, you probably have seen it before. At this current moment, you probably had it 7th grade, 8th grade, 9th grade at some point in time. It's been done, SOH CAH TOA. So I'm going to go through and actually try and teach it slightly different. So from here, everything that we're doing actually has to do with a reference angle. So my reference angle on this one right here is going to be my theta. So I'm going to mark my reference angle right here. This is the reference angle. So what we are learning from Monday is we are labeling our sides. So from here, I'm going to draw an arrow across that. So from there, so what is that going to be? That's going to be my opposite side, right? That's what we learned on Monday. So my opposite would be side BC and hypotenuse. Hypotenuse is always located where? Across from the very good. Across from the right. So from my right angle, I'm going to draw an arrow right there. So that one right there is going to be my hypotenuse. So that's going to be my AB. Now, keep going on this. So let's do the same thing over here. So now, this is my sine ratio. Sine is always my opposite over hypotenuse. My cosine ratio, again, my reference angle. Identify my reference angle here. Across from that, that one's going to be my opposite, right? Am I looking for opposite here? No. Nope, I'm not looking for the opposite. But I needed to identify opposite first. So I'm going to put an O right here. Here, let me do this also. Opposite, hypotenuse. That means that my third side right here had to be my adjacent. Very good. Okay, so I identified my opposite. Now, after I'm done identifying my opposite, identify the hypotenuse. Across from the right angle, draw my arrow. That is my hypotenuse. And that means my third leg of my triangle is adjacent. So, now that I have it all labeled, my adjacent side, which be which side? Say DF. DF. And my hypotenuse is DE. So DF and DE, there is my cosine adjacent over hypotenuse. My tangent, so I'm going to keep labeling it. So my reference angle here. So draw my arrow across from my reference angle. So that one's going to be labeled my opposite. Very good, opposite. Call that O. Here's my right angle. Draw an arrow across. That one is my hypotenuse. And my last one is adjacent. So now my tangent's looking for the opposite, which is MN. And adjacent is NL or LN, right? So that's what I have it labeled as.
And adjacent is LN.
Adjacent is LN right here with the A. So for this one right here, there's another acronym, but we're going to get into that later for SOH CAH TOA. So let's take a look, finding all the ratios. Now, they're using theta, and they also use Greek alpha, A. You don't always have to use, the same thing to actually categorize my angles. So this usually signifies my angle. I could use an alpha, I could use a beta, I could use X. I could use a bunch of different things to identify my angle that I'm using. But for right here, find all the trig ratios for each angle. So now I have alpha here and I have theta here. So sine of theta. So let's see. If this is theta, so that's where my reference angle is. That's where I'm starting. Sine is what? Let's go back to the top. Sine is opposite over hypotenuse, right? Opposite over hypotenuse. So for sine here, opposite of my theta is 3. 3, right? Over my hypotenuse, in this case, is 5. Very good. So now let's take a look. Now, still from theta, I'm doing tangent now. Tangent is opposite over adjacent. So now from this one, opposite this side is 3, and adjacent is? It's 4, right? So I'm going to write 3 over 4. Cosine is adjacent over hypotenuse. So that's going to be adjacent is 4, hypotenuse is 5. Now we're going to go at it from alpha. So we're changing my reference angle now. So this is important to understand. So now from here, what is opposite this side? 4. That's important. That changes my opposite and it changes my adjacent. Does my hypotenuse ever change? No. It's always across in the right angle. So let's take a look at cosine now. So now from alpha, right here, cosine is adjacent over hypotenuse. Now adjacent to alpha is, it's 3, isn't it? It's going to be 3 over, very good. Now tangent is opposite over adjacent, so opposite of my alpha. So it's 4 over, okay, 4 over 3, very good. Sine of alpha, sine is opposite over hypotenuse, right? So opposite of my alpha, 4 over 5. So it differs according to which side is my reference angle. That is the most important key to starting out all these problems, is my reference angle. Now let's do this one over here. Sine of theta. So if this is theta, sine is opposite over hypotenuse. So opposite of theta?
15.
Over? Very good. 15 over 17. Tangent of theta. Tangent is opposite over adjacent.
15 over 8.
Very good. 15 over 8.
Can it be opposite too?
Do what?
Maybe 8 over 15.
No, it cannot, because if this is theta right here, right? Opposite is only this way, right? You only have one opposite. So think about it like this. You ready? So if you're thinking about it like this, okay, the opposite side of my room. If I'm starting right here, the opposite side of the room is over there, isn't it? Is it possible to have another opposite side? Not really. It's just opposite that. Does that make sense? So they only get one opposite. All right. Cosine. So cosine of theta. Cosine is supposed to be adjacent over hypotenuse. Adjacent is?
8.
8 over 17. Now we're doing it from alpha here. So from alpha, what is cosine of alpha?
Adjacent over hypotenuse.
Adjacent over hypotenuse, so that's going to be
15
over 17. Tangent of alpha, tangent is opposite over adjacent. 8 over 15, right? Tangent is opposite over adjacent. So opposite adjacent, because 17 is my hypotenuse. Okay, so it's going to be 8 over 15. Now, sine of alpha, sine is opposite over hypotenuse.
I was thinking about that one.
Yeah, there we go. Sorry about that. 8 over 17, right? What do you notice about sine and cosines you found? What do you notice?
They switch.
They're switched, right? Okay. So we could say that sine theta is equal to cosine of alpha, right? Sine theta is equal to cosine of alpha, right? Is that the same on both of these? Okay, and what else do I know? I know that cosine of theta is equal to sine of alpha. Okay, do you think this will be true? Yes. So, do you guys think this is always going to be true?
Yes.
Yes, and I'm going to tell you guys why. So, yes, it is going to be true. And because they are complementary. Now, complementary means what? Adds up to 90, right? Adds up to 90. Since they're going to be complements of each other, it's always going to be like that. They're complements of each other. So if I'm going through this, A and B are acute angles right here. Sine A is equal to cosine B. That's what I just figured out up here. Cosine A is equal to sine B. Therefore, theta is the measure of an acute angle. Then sine theta is equal to cosine of 90 minus theta. Okay, and vice versa. So these are important because you're going to need this here momentarily. So, if theta is 30, and I said that they're complements of each other, so let's take a look up here. If theta is 30, and they're complementary, that means that together they have to add up to, say 90.
90.
They together have to add up to 90. So if this one here is 30, so it's same as saying 90 minus 30, so my other angle would be 60. So let's see if you can figure this one out. So sine of 30 is equal to, so sine of 30 is equal to cosine of what? Cosine 60. So because these two angles together have to add up to 90. So if theta is 30 and alpha was this one, 90 minus 30 would give me my 60 here. And so vice versa. So cosine of 30 is equal to sine of 90 minus 30, which would be 60. Okay, so that's the same thing as it means right here. So cosine 30 is equal to sine of, so it's basically, all I'm trying to get is the fact that sine of 30 equals cosine of 60. Okay, these two angles together have to add up to 90. So if you have one, can you find the other? Say yes. If you have one of them, just take it away from 90. That's what it is. If you have this one, 90 minus that is going to give you this angle over here. Kind of makes sense? Yeah. Okay. Make sure you guys... Alright, so I wanted to look at the practice real quick. Okay, so let's look at the practice. Here it is right here. On the back side. So right here, we're going to go through. So I'm starting with the back side to show you guys what we're doing. So find the value of each, round each answer to 100. How many place values is the 100? 2. So in your calculator, make sure it's in degrees. It should say degrees on the upper right-hand corner. So put cosine 10, enter. Now, on these ones right here, label your triangle first. If this is my angle, cosine is supposed to be adjacent over hypotenuse. Now, let's label it. So first, this is my opposite. This is my adjacent. That is my hypotenuse. So cosine is adjacent over hypotenuse, so cosine theta is equal to 15 over 17. Does that make sense? You just have to write out the fraction. And over here, you have to label using W as your reference angle. So W is your reference angle. Label it with H, A, and O. Do the same thing for these, and using theta as your reference angle. Make sense? Okay.